Hello, good evening, and selamat lemai. My name is Kelvin, anak George Charles, and today I would like to present on the design of three-phase horizontal separator with Excel programming under Natural Gas Engineering, taught by Dr. Nazri Abdul Rahman. So there will be four presentation outlined this evening, which are the introductions, research methodology, result and discussions, and lastly, conclusion. So the introduction, what is three-phase separator? So three-phase separator are equipped with bucket and wire, as shown here, to control the interface between heavy and light liquid. As shown in figure 1, three-phase separator is divided into three sections, which is the entrance zones where the feed is coming in into the vessels, gravity separation zones where the heavy and light liquid is separated and along with gas, and lastly the overflow zones where the products are distributed in three processing lines. What is the aim of this project then? Then is to develop a three-phase separator wire by Excel programming. So two objectives need to be executed to achieve this aim, which is to develop a three-phase horizontal separator and to integrate a user-defined system in the Excel programming. So the scope for this project is focus on the hydrocarbons, waters, and using the method from Gas Processor Association Standards, GPAS. So the research methodology as to achieve the project's three stages has been formed. So the first stages is to select assumptions. Second stages is to design the equations. So we refer to the literature reviews and books. And lastly, to achieve objective 2, we integrate the Excel programming with user interface system. So the result and discussion, selecting assumptions. So these are the assumptions that has been used to design the programming. So most importantly, the calculation method is based on the Gas Processor Association Standard GPS, and the feed composition is 1% water, 4% hydrocarbon liquid, and 95% of hydrocarbon gas. So whereby the density and viscosity of the hydrocarbon gas, liquid, and water are provided. This value is selected from literature review as suggested by Wang 2009. So the stage 2, design of equations, begin from step 1, where we calculate the vapor volumetric flow rate. From this step 1, and comes to step 23, where we can formulate the weight and full diameter of the vessels. So this is the user interface, where the input parameter has been designed in a series of cells in the Excel, including the operating condition for the separator, properties of light liquid, properties of heavy liquids, and properties of hydrocarbon gas. So we see the assumption is shown here. So the design specifications in this project is shown in this table figure 4, where the diameter, length, and normal liquid level and normal low liquid level is shown here and has been calculated by the equations. So the most important here is the implementations of call functions. So the first call function is if. So in this condition is to determine the ratio between length and diameter. So should the operating pressure is beyond 500 psi, then the L over D is 4.1, and it same happen if the operating pressure is more than 250. The system will select 3.1, and should the value is less than 250, then the L over D is 1.6. So the same goes for the minimum function. We're using the maximum equations. So we're rounding off the equation into 1 decimal places, which is 0.5. So the next is the vessel type selection. So this will be referred to the appendix in the next sheet. So the system will be able to select either the spherical, the separator type is hemispherical, discus knuckles, or ellipticals. And lastly is the VLOOKUP. So VLOOKUP is important, where it can select the various data in the appendix as shown here. So the next is the user interface. So this program is very friendly because the user needs to press the launch buttons and the user input will come out here. So the user just need to key in the designated values, and in the end the result will be coming out here. So the designer will be able to extract the information easily. So conclusions. So Excel programming is used to design a three-phase separator, and secondly, Visual Basic application has been used as part of the user interface. And lastly, let's run the Excel programming together. So we begin by clicking the launch button. So we just need to key in all the information here, but that's okay. I will fast forward the value after this. Now I have completed fill in all the required information. So let's press the calculate button. As you can see, the result reappear where the design is ready. So the result shows the vessel diameter at 8.7 feet, the minimum length, the total length, the wire length, and the feed rate is at the last. So the vessel weight is about 5,800 pounds. So you can press OK. If we want to reset the values, we can just press reset button, then all the information will disappear. So if you want to exit the system, just click here, confirm. If you want to exit, press yes. Now we finish with the tutorial. So let me go through with the Excel programming here. So this is the overall size of the Excel programming. It consists of 23 steps. And you can see the appendix tables, which the data is having called here using if-else functions and VLOOKUP. And the macro inputs, yeah, this is from to show the direction to the user forms, and this is the final output that will be shown in the user input diagram. So that is all from me. Thank you for listening to my sharing, and have a very good weekend.